All right, welcome back to video number 3 of 5 in my Intro to Mathematica for Linear Algebra series. In the last couple of videos, we've been going through some of the basics of Mathematica, and then in the last video kind of ended on the idea of solving systems of equations within Mathematica, and of the 3 different varieties, whether you get a unique solution, no solution, or infinitely many solutions. So you can refer back to those videos to kind of review the idea on that. In this video, we're going to take a little deeper dive into some of the other built-in codes that Mathematica that can be useful for your linear algebra project. We saw the solve one last time, but we have a number more we want to go over. So let me share my Mathematica screen with you all. All right, and so just like every other video, we have our notebook file here where we are already in our line of code, and so we're going to go from there. So I'm going to begin by defining a couple of matrices here for you. I'm actually going to use the same 2 matrices that I did back in video number 1. So if you've been following along more recently, you probably remember these 2 matrices, but let me redo them just for my new notebook file. So we are going to do matrix A. Ooh, looks like it's actually black, so let me clear A real quick just to make sure. There we go. So, and actually I'm going to use B as well. So let me go ahead and clear both of those just so I'm aware. There we go. So I'm going to let matrix A be 1, 2, 3, 4, 5, 6, and 7, 8, 9. Input that. And then I'm going to let matrix B be equal to, what was that? 0, -1, 4. 3, -2, -1, and -7, 8, 0. And so these matrices should look familiar. In video number 1, I showed you how to add them, subtract them, and multiply them together, and we successfully talked about all of that. So what I want to do is I want to go through a few things that we may have already covered during lecture, and I'm going to do my best to try to remember exactly what section they're in, but I might have to refer to chapter because some of these run together since I'm making these videos pre the semester starting. So starting with the first one, we're going to talk about transposing a matrix. And I believe we covered this in chapter 2. The idea of transposing a matrix just means you're going to take each column of the matrix and make it a row, or you can think of it as you're going to take each row of the matrix and make it a column. So if you ever need to transpose a matrix in Mathematica, we're going to use the built-in code transpose, type the whole word out with a capital T, and we're going to have Mathematica. Let's just do A to start off. So I want to transpose matrix A. And so remember, if you want to see it in a better syntax, you can include the code matrix form around what you're trying to do. So I want a matrix form transpose of A. And you'll notice instead of the 1, 2, 3, 4, 5, 6, 7, 8, 9 running across the rows, now they run down the columns. And you can do that for matrix A. If you meant to do it for matrix B, you could also do that as well. So if you ever need to transpose a matrix, which hint, hint, you will on your project, all you do is do capital T transpose, open bracket of whatever matrix you're trying to transpose. Great. Then we talked about determinants in the first video of how to use the Google search. So let me show you how you do determinants actually in Mathematica. So determinants are what we spend our time in chapter 3 talking about. If we haven't got there yet, means we probably haven't covered them yet. But in Mathematica, if you want to do a determinant, you actually don't spell the whole word determinant out. It's actually been shortened to be capital D and then ET. And so if I ask Mathematica to find the determinant of, let's say, matrix A, it can do that, and the answer comes out to be 0. Or if I ask Mathematica to find the determinant of B, it can do that, and the answer is 33. And so once you've defined the matrix, you can find its determinant very quickly by just doing DET of whichever matrix you're trying to worry about. Now, one thing with determinants is that you might want to use these numbers and kind of put them all together as a final answer in more than one way. So here's one thing you might note. One of the problems on your project might mention something along the lines of use the built-in list function in order to list all your answers in one compact format. I want to show you how to do that. It can be done with a bunch of different codes, but for this video, I'm going to use it with the determinant. So what I would do is, if that's just the answers I want, two ways you can do it. Number one, you can just do list, open bracket, and then you can tell Mathematica what values you would like to list. I want it to list the determinant of A, then list the determinant of B, and it will do that. It will do 0, 33. Now, I would encourage doing it that way if it's something short to type in. Now, what you'll also see is that some of the codes we're going to look at, especially in video number 5, some of the codes are a lot longer, and we don't want to type all of that within the list code. So here's a different way you can do it. Whenever you find whatever it is you're trying to find, let's just say determinant of A, what I could do is I could call this lowercase a. Just call it something else. You can call it A, whatever letter you want. And so if I just say that I want lowercase a to be equal to this code, whatever it may be, likewise, I want determinant of B to be equal to lowercase b. I would approach it this way: is if the code you're trying to input into list is really long, I would just define that complicated code as some random lowercase letter. Because once you do that, then you can have Mathematica do list, and you can just list the lowercase syntax that you defined your more complicated code as. So if I do the same thing here, it should output the exact same answer. Or if you prefer to put B first and then A, you can also do that as well. So if you see the word, a hint, use list, this is a couple different ways you can do it. You can list exactly the code you want to list, or you can define the code elsewhere and let it be equal to a random letter, and then have Mathematica list whatever those letters you define are. So, but either way, that's how you find the determinant of a matrix. The next thing we want to talk about is inverses. So we actually do inverses in chapter 2. So you can have Mathematica take the inverse of any matrix. So this one actually is a full type out. We're going to do capital I for inverse, and let's just start with matrix A. I want Mathematica to find the inverse of A. Oh, you see a problem. I did this on purpose. This says that the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 is considered singular. You might remember from in class, we talked about the idea of singular versus non-singular. Singular means that a matrix is not invertible. That's why it did not give you an answer. So if you are working a problem and you ask Mathematica to find the inverse of a matrix, and it spits out that it is singular, that means it's not invertible. So you need to double check, does that make sense for the context of the problem you're doing? Or do you need to kind of look at what you typed in or how you defined your matrix to ensure that you're getting the correct output? Now, if it does work, let's see if inverse B gives me an answer. So inverse of B. So you see that one does give me an output. So if I want to put it into the better syntax, I can go back and add matrix form. And this would be the inverse of our matrix B. So remember, inverses don't always have the nicest numbers out there. So it's okay because we had Mathematica do the work for us. And so that is how you would do the inverse of a matrix. All right, one more thing, and then I'm going to combine a couple of these things together to show you that you can do more than one thing at a time. Let's say that we want to find eigenvalues and eigenvectors. Now, eigenvalues and eigenvectors is what we spend chapter 5 talking about. So we may not have made that far in lecture yet. If so, I'm still going to show you how to do it in Mathematica, but in order to fully comprehend what those numbers are telling us or how they're found by hand, we will cover that in chapter 5. But as far as Mathematica goes, we can use the built-in code eigenvalues, and they did not shorten this, and you'll see why in a minute. And you can have Mathematica find the eigenvalues of whatever matrix you've defined. So in this case, we're going to do the eigenvalues of matrix A. You see come out to be 3/2 times 5 plus root 33 3/2 times 5 minus root 33, 0. Notice that this is not a matrix. This is just three numbers listed because eigenvalues are listed as just numbers. You could also have Mathematica find the eigenvalues of B. Now, in this case, you will notice that there are these little i's here. You might remember from a previous math class that I represents imaginary. So imaginary numbers are possible when it comes to eigenvalues. We will talk about complex eigenvalues in chapter 5, so we can talk more about what those do and how they yield different results when it comes to applications of eigenvalues and eigenvectors. Now, on top of eigenvalues, I've been saying the word eigenvectors, so you can also find what an eigenvector is within Mathematica. So once again, there's no real shorthand code here. You must type the full word out, eigenvectors, because there's no eigen-v or eigen, because since both these words share so many letters in common, Mathematica just chose not to give a shorthand notation for both of these. But if you have Mathematica do the eigenvectors, it will spit those out. Now, what you need to note, and once again, this will make a lot more sense if we've covered chapter 5 in class. If we haven't, I would recommend you come back and listen to this explanation after we've covered chapter 5 in class. Each of these vectors, so let me highlight this first one. This is one of the eigenvectors of your problem. There are two other ones listed right next to it. This eigenvector, which is the first one, matches up with the first eigenvalue that was listed earlier. And you will learn in my class that matching the eigenvalues and the eigenvectors up is necessary to be successful in the applications that we cover at the end of chapter 5. You cannot just match up whichever eigenvalue you want with whatever eigenvector you want. This is why Mathematica spits them out in a particular order, so make sure you keep in mind. These first two eigenvalues do have more complicated eigenvectors. The eigenvalue of 0 has a little bit more of a direct eigenvector. And once again, we dive into all of this during the lecture part, so if we have not covered chapter 5 yet, we will get there, I promise. Let me also do eigenvectors of B just so you can practice one with complex information. So if I do the eigenvectors of B, typically if you have complex eigenvalues, you're going to also have complex eigenvectors. So as you can see, it does spit out a bunch of complex eigenvectors. Once again, we are matching the first eigenvector with the first eigenvalue, so on and so forth. And so make sure you know how to find both of those. It will be necessary for a couple of problems on your project. The last thing I want to do for this video is show you that some of these things that I've covered in this video can be done at the same time, and that will actually be very beneficial as I move into some of the topics in chapter 6 in the 5th video that I'm going to make a little bit, that you'll watch a little bit later. So let's say, and one of the more popular ones that we're going to see is you might have to do an inverse and a transpose at the same time. So let's pretend that I want to take the transpose of an inverse of a matrix. So what I would have Mathematica do is I would do transpose like we did earlier in this video, but I just don't want to transpose a random matrix. I want to transpose the inverse of a matrix. Now you might remember earlier that the inverse of A did not work, so I'm not going to use that one. Instead, I'm going to do the inverse of B. And so if I close all of my appropriate brackets, this is essentially telling you that I want Mathematica to work from the inside out. I want it to find the inverse of B, and then I want it to transpose that matrix. And there you go. Mathematica will do that. And like I've always told you, if you get an answer that you think is right and you want to double check it, you can always put the code matrix form in, and it will put it in a more, I guess, prettier syntax. Now, bringing back something earlier that we did in a different section in the first video was multiplication. So let me add one more thing to that. So we got transpose of inverse. Oh, I spelled transpose wrong. You see, it was still blue, so I knew that. Transpose inverse of B. And then I want to multiply that matrix by the matrix A. So remember from the first video, if you want to do matrix multiplication, you will use the period on your keyboard and then multiply it by whatever matrix you want. So in this case, we get an answer. And so that looks legit. It looks okay to me. So I'm going to now add matrix form around this. And we can make it look a little bit better. And so it's okay if you need to combine multiple different built-in codes within Mathematica. Just make sure that when you have your formula written down or you're applying a formula that we did from lecture, please make sure that you are typing it in the exact way that you want Mathematica to do it. So on both of these, I wanted it to find the inverse of B. I wanted it to take the transpose of that and then multiply that by matrix A on part 2. And so that's going to put a wrap up on video number 3 of this series. So we spent the last little bit going through some of the built-in codes within Mathematica, kind of showing you how they work. Some of them we've probably covered during class already. Some of them, if we have not, don't worry, we will. You can always come back and watch this video later. It'll be on Canvas the rest of the semester. That way you can refer back as you're working on your project. In the next video, we are going to move into the other idea in this class, which is also vectors. So we've done a little bit of vector talk, probably during lecture already. What I want to spend a little bit of time talking about is how do you do vectors within Mathematica? And so I will do that in video number 4. See you then.